Hi dear student friends, myself Manjunath PC, working as a Senior Assistant Professor in the Department of Computer Science and Engineering, Reva Institute of Technology and Management, Elhanka, Bangalore. So, in continuation with my previous sessions, I will be taking you on functions, arrays and strings. And before we proceed with this session, so let us see what we have discussed in the previous session. So, in the last session, we have seen a two-dimensional array of characters which we called as strings, and in that we have seen a look into a concept of pointers, which is a very important concept in C programming language. And then we have seen how the arrays and pointers are related, and we have seen some of the pointer arithmetic operations, and also we have seen the pointers and strings, and later we have seen some of the programs related to the strings, and also we have seen the string handling library functions. So, C supports certain library functions which are exclusively meant for manipulation and operations on the strings. So, and we have seen certain programs that makes use of the string handling library functions, and also we have seen a program to search for a particular name in a list of names using the binary search technique, which is one of your lab exercise program, and we have seen how to program that and how to find a particular name in a given list of names. And we have seen that here the names are to be a sorted order. The input what we supposed to take in this program should be in the sorted order only, because that is in the alphabetical ordering, because we are performing here the binary searching technique, and this binary searching technique will works only on the sorted list of elements. And in this today's session, so we will see a concept of functions which are very most important in the C programming, and we have seen we will see what exactly the advantages of functions and how to use the functions in C we will see, and we will see syntax of function prototype, function definition, and how exactly the function need to be called, and we will also see the categories of functions that we can find so in C, and also we will see some of these simple programs on the functions, and finally we end up with so looking into a lab program, so which is the 10th lab program as per the syllabus. And so coming to the functions, see here a complex problem is often easier to solve by dividing it into several smaller parts, each of which can be solved by itself. See here, when we have given with a complex problem, solving the problem complex problem in one shot is very difficult. So what we do normally is like we divide the complex problem into sub problems, and handling of this particular sub problems will be easier, so that we will divide that into sub problems, and after solving the results of, after computing the results of sub problems, we finally conclude the result of the computational result of the given complex problem. So here each sub problem is more manageable than the original problem. So handling the original problem in one shot is quite difficult, so we divide that into sub problem, and handling this sub problem is very easier and easy to manage and easy to know how exactly the operations need to be performed in the sub problems. And this way of programming, where we divide the given problem into sub problems, we solve the sub problems, and then we gather the results to get the result of the original problem. This method of programming we call it as a structured programming. This says that the C language is a structured programming. So in the higher semester you study C++, which is an object oriented programming, whereas here the C which based on the procedures or the functions, we call this as a structured programming. These sub problems basically in programming we call it as the functions or procedures or modules. So the sub problems can be implemented in the programming by means of a functions, procedures or modules with respect to the C programming language. And finally the result of the sub problems is collected by the main function. So and finally the original problem will be solved. We will see how exactly the main will make use of the sub functions, or we say like functions, procedures or the modules, in other words the sub problems, to get the result of the original problem. Now, so what are the advantages of these particular functions? So the main advantage here is like these functions will separate the concept from the implementation. The concept means what is to be done, it is separated from how it is done. Say for example in the programming, so just to print a string on the screen in C, we use the function called printf. So we doesn't know how exactly the printf performs the operation, but we know that what is the result of the printf. Whatever the string we give there as a parameter, that will be get displayed on the screen. So that is what here what is done. So it is different from that of its implementation. The functions will allow separation of the concept with respect to their implementation. So, that is, we doesn't know really how exactly the printf is implemented, but it is available in the library. We are making use of this particular function printf. Similarly, the scanf also, how exactly it is implemented we are unaware, but we make use of this because we just know what is to be done using this particular function. How exactly it is doing we are unaware. So, this is main advantage with respect to the concept of functions, so which are easy to handle the sub problems of the main problem. Now, the other benefit of this using these functions is like functions make programs easier to understand, thus improves the readability of the program. So, when you have the functions, understanding the sub problem is more easier compared to the understanding of the entire problem itself. So, when you go on understanding each of the sub problems, so finally in other words we will be understanding the entire complex problem given. So, and hence, so this particular function concept will improve the readability of the program. We can easily understand the programming, so or the complete complex problem, how exactly it is programmed, we can understand by means of understanding each of the sub programs or the functions. So, thus it improves the readability of a program. And one more advantage of using the function is like functions can be called several times in the same program, allowing the code to be reused. Say for example, in a simple C program which we have seen so far, we have used several times the printf statement. The function printf performs thus just printing a string on the screen, but in the several times we will be using that printf function. So, thus the code associated with the printf is being reused there. So, thus we can reuse the functions, so reuse the code segment, making use of the concept of functions. So, these are the major advantages what we can get with the use of the concept of functions. Now, so how exactly the functions are supported in C? The C allows the use of both user defined functions and the library functions. C supports two types of functions basically here, the user defined functions and the library functions. Basically, sometimes in some context we call the library functions as the internal functions, whereas user defined functions as the external functions. So, basically they are user defined, so defined by the programmer, and library means it is already available in the library, and we have already used some of the library functions in the previous programs. Say library functions means printf, scanf, getchar, putchar, or abs, which is to compute the absolute value of a particular number, then ceil function, which is to find the ceil value of a number. So, similarly the rand function, which computes the random number generator, which will generate a random number. Similarly, we have sqrt function, which computes the square of a number. So, these are already available in the library. So, likewise, so we can have plenty of functions available in the library. Say for example, in string.h we find so many functions related to the strings, and in case of stdio.h we find so many functions related to the standard input output header, and similarly in case of conio.h we find the certain functions related to the console input output header, and so on. Similarly, in math.h we find certain functions which are related to the mathematical concepts. So, these are stored in a separate library, a specialized library is called the header files, say stdio.h, math.h, string.h, and so on. When you are using sqrt function or the rand function or something like absolute value, so something like that, when you are using the functions which are related to the mathematics, so then we have to make use of, or we have to include the header file called the math.h. These are already available ones. So, we are going to use that in our programming based on our requirement. These functions are called as a library functions, right. So, now we will see how exactly the user defined functions can be included in our programming. User defined means here the programmer is going to define the based on his requirement what exactly the function has to do. Now, so with respect to this, so if you see a function, so whichever the function, whether it is a library function or a user defined function, normal behavior is like it will take certain set of parameters, certain input it will take, and performs the operation. So, within the function body, whatever the instructions are given, based on that it performs the operation, and finally it gives us the result. A normal form of a C programming, when we see the C programs usually have the following form. So, here first what we do is we include the statements, that is include stdio.h or conio.h or math.h. These are the file inclusion statements which are the preprocessor directives. That is the first starting lines of what we normally do in programming. Followed by we use function prototypes. We have not seen so far what exactly the function prototype is. In this session we will see what exactly these function prototypes are, and then we will write the main function, and finally we define the function definitions. The concept of function definition and function prototype we will see in this particular session, how exactly user can define his own function to make use of solving a complex problem by dividing that into a sub problems. Now, so this is normally the forms of a C programs generally looks like. So, for inclusion statements, then for function prototypes, then main, the major function which has to be included, and then the function definitions, which are the user defined function definitions we include there. Now, consider the function prototype. So, this is a syntax of the function prototype. So, we must be very careful when you are looking into the syntax of the programming constructs. So, here the syntax says like, first you have to mention the return type of the function. This is the return type can be any kind of data type. It could be of basic data type, or it can be of derived data type. Basic data type in the sense is the int, float, char, double, long double, short, whatever it could be. So, here this return type specify the type of data that the function is returning. So, now the name of the function, the second one is function name. This could be any valid identifier. We know the rules of specifying an identifier, the way we define the array names or the variable names, the same way we can name even the functions also. This is an identifier, and then it will take certain parameter list, and make note that this is ending with a semicolon. This is the function prototype syntax. It is not the function definition, it is a function prototype. In some context, we call the function prototype also as function declaration, like a variable declaration. We declare even the function also. When you see the examples, you will get to know that what exactly the meaning of function prototype. Sometimes these are also called as function signature. Function signature, function prototype, function declaration all mean the same. We specify the return type, name of the function, and within the parenthesis the parameter list, and this must end with a semicolon. This is a syntax of the function prototype. Now, so here, so return type means data type of the result returned. What type of data the function should return after performing the operation, that is specified as the return type. So here, if the function is not returning anything, then we can specify that as a void. Void is a special data type whose size is 0 bytes. That is, we normally do not declare any variable of type void. We declare only the variables of type int, float, char, and so on. Then the reason is like, so the size of the void is void data type is 0 bytes. It does not so allocate any memory even if we declare the variable of type void. So is the reason C language does not allow programmer to declare a variable of type void. But in case of a return type of a function, we specify a void wherein we mean that function is not returning any particular data there. Then is the name of the function. Function name could be any valid identifier. We know the rules of naming an identifier. The same nomenclature we can use even in case of a function name also. It could be of x, y, z. Normally we do not use the single name as the function name, single symbol as the function name. Rather we use some functions names like something like a display or print and so on. We will see in the examples how exactly we name the functions here. Then is the parameter list. So here within the parenthesis we have to specify the parameter list. So this particular parameter list specifies how many parameters the function is taking. So here comma separated list of arguments. So here each parameter should be separated by the comma. Now the data type needs to be mentioned for each argument. If it is taking 3 parameters, then what is the data type of each of the parameter, that also should be mentioned in the function parameter list here, right? This we call it as a parameter list. And if no arguments are used, then we can use again here void, or leave a blank space. If you are not mentioning any parameter list, it means that function is not taking any parameter. That can also be mentioned by mentioning a void there. When you specify void, it means that function is not taking any parameter there. Note that it has to end with a semicolon. This is a function prototype or a function signature, or it's also called as function declaration. Now see an example. So here the display is name of a function. So here this is a valid identifier. So we are using the alphabets, and we can also use even the digits and even the underscore also. Only thing is the name should begin with either a letter or with an underscore. That is the rules of the identifier. And I specify the return type of the function as void. The reason is this function is not returning any valid data there. And also here as the parameter I am specifying here as a void, it means that this particular function display is not taking any parameter. Now similarly I am declaring here another function called a print underscore data. This is another function, print data, which is not taking any parameter. When I am specifying void here, it means that it is not taking any parameter. So that is also be conveyed without specifying anything within the parenthesis here. Here I am not mentioning void, but still it means that this particular function is not taking any parameters there. But what is the return type of this function print underscore data? If you look at its return type is integer, means it is performing certain operation and finally it is returning an integer type of data as the result. That is the return type of the function print underscore data. Now if you look at the function xyz, so here I am not mentioning the return type of the function and even I am not mentioning any arguments in the parameter list. So here it means that this function is not taking any parameter, but what is the return type here? When you are not mentioning the return type, the default return type is integer. That is how the C will conclude. If you are not mentioning the return type of a function, so then it means that the return type of the function is an integer. So when you are writing a program, normally we write like int main. If you do not write int there, even if you write simply a main, so then even then the return type of the function main is like a integer only, because the default return type of any function in C programming is of type integer. Now if you look at some other examples here, now ABC is another function, name of the function, whose return type is double and it is taking 4 parameters here. You can see like the 4 parameters here, and each of the types we have mentioned here. Int, the first 2 parameters are of type integer, the third parameter is of type character, and the last parameter is of type pointer to float. We have discussed the concept of pointers in the previous session, and here float star indicate that the 4th parameter here, what the function ABC is taking is a pointer to a data of type a float, and here each of these arguments must be separated by a comma. Fine. So finally we have to end this with a semicolon. All these are function prototypes. Fine. So are the function declarations or the function signatures. Now if you look at another function, absolute is the name of a function which is taking integer as a parameter and returning an int data as the result, as the return type. And another example is print underscore array is another name of a function which is taking a pointer to float and 2 integers as arguments. Altogether it is taking 3 parameters. One is pointer to float, the second one is integer, and the third one is also of type integer. These are the parameters what the print underscore array is taking, and the return type of the function print underscore array is void. Means what? This particular function is not returning any valid data there. This is the way how exactly we can define, we can have the function declarations or the function prototype or the function signature. Next we will see the function definition here. Now if you look at this particular the syntax of the function definition, it is more or less similar to the function declaration, but here the major change is like we have the body of the function here. Return type is common in case of function declaration also. Function name, this is also common with respect to function declaration, and the parameter list is a bit varied here. The way when you use in programming you will get to know that what is the difference between the function definition with that of the function declaration. And here we have to note that we do not use here semicolon, no semicolon. In the case of function declaration we end with a semicolon, whereas here a semicolon is replaced by a body of the function. We specify here the body of the function. Here we are trying to give a meaning for a function, what exactly the function has to do. So when we look at the function declarations, so here in the previous case he will not be knowing that what exactly display is doing, print underscore data is doing, or absolute is doing, or print underscore array is doing, or xyz is doing. These are just, we know that there are the functions, they are taking so and so parameters and returning so and so of type data, but we will not be knowing that what exactly they are trying to do in the body of their function. So here we specify the body of the function here, but when you are specifying the body of the function, these parameter list we call it as the formal parameters. When you start coding, when you start programming this, making use of this user defined function, you will get to know that how exactly the parameter list need to be mentioned in case of declaration and even in case of function definition. Let's see one example of this. Now here you can see like absolute is name of a function and it is taking an integer parameter which I am naming it as here x, and here I am not ending with a semicolon. You have to make a note of that. In case of declaration we end this with a semicolon, whereas here we do not end with a semicolon, rather we will be having the body of the function. Here we can clearly know that what is the task that the particular function is doing. So now also the return type of this function is a integer type. Now, what exactly this function is doing? It is taking a parameter as x as an integer type, and here if x is greater than or equal to 0, it returns x. We are computing the absolute value of an integer data, right. So, if it is a negative value, absolute value will be its the positive value. Now, if x is greater than or equal to 0, the return x, and else it is returning a minus x. And here we can see that we do not have the main function here. This is a user defined function. I am calling this function as the absolute. Now, so look at another function. So, name of this function is check even odd. It is going to check whether a number is even or a odd number. It is taking again an integer type of data. Here we can specify any names, like a normal variable declaration. I can declare here any name. Here we are calling these variables which you are going to declare. So, in the functional body as the parameter list, here we specify this as the formal arguments. N is a formal argument here, or the formal parameter, and here x is a formal argument or the formal parameter. Now, the return type of the check even odd is function check even odd is also integer type. What exactly this function is doing? If n mod 2 equal to 0 returns 1. So, whenever the number is an even number, this function is returning 1, otherwise it is going to return the value as a 0. Whenever this function returns 0, it means that parameter what we have passed is not an even number, and whenever this function is returning 1, it means that the parameter what we have passed is an even number. Fine. If it is returning 0, then it is an odd number. This is here we can see, like in case of function definition, we are trying to give a meaning for the function. We will get to know that what exactly the function is doing within the body of the function. In case of function declaration, we just specify a return type, name of the function, and the parameter. That's it. We do not know what exactly the function will do there. So, that is what. So, just what a function is, what parameter it takes, and what is the return type. That is the only thing what we can know in case of function declaration or function prototype, or in case of function signature. Whereas, in case of function definition, we can exactly know what exactly the statements are included in the body of the function and what exactly the function is computing there, and we can get to know. So, only in case of function definitions. Now, with respect to the main function, we have seen that when you are using the main function uses the user defined function to solve the original problem. So, we have seen like original problem is divided into sub problems, and these sub problems are used in the form of a user defined functions in case of a C language, and finally the main function will make use of the sub functions in solving the original problem. But let us see how exactly the main function make use of that. And it is also like every function can make use of every other function by making a function call. Here we use one term called a function call. How to make use of a particular task that a function performs. So, here by means of function call, a function can call another function and performs the operation here. Say for example, now the syntax of function call is like name of the function and then the argument list, and here we have to see that we are not mentioning the return type here. When you are making a function call, we do not mention the return type. So, here just we call the function by means of its name. Say for example, printf we have called many times in the previous programming. So, wherein printf is a function, and we have passed even the arguments also. The string which you are passing, which is an argument to the function printf, whatever the string we pass there, it will be printed as the output there. Even for the scanf also we passed certain arguments which based on which it reads the data from the keyboard. So, here the syntax of the function call is like name of the function we should specify. Within the parenthesis we have to mention the arguments that are to be passed into the function, and we have to note that this is ending with a semicolon. So, here only in case of function definition we do not have a semicolon, rather in case of function call and even in case of function prototype we will be ending with a semicolon. Now, and these particular arguments what we are passing to the function here, when you are calling a function, we call these arguments or the parameters as the actual parameters or the actual arguments. In case of function definition, we call the parameters as the formal parameters, whereas in case of function call, the parameters what we are passing, we call it as an actual parameter. Maybe in the next session you will get to know that why is that we call this as arguments or actual parameters, whereas in case of function definition we call it as a formal parameters. Now, so this is an example. So, I am calling a function called absolute. I am passing x as a parameter. X should be of type integer in case the absolute function is taking integer as the data. The same type of data what the functions are taking, the same type of values we are supposed to pass them as a parameter. Similarly, here I am calling a function called sqrt, which is taking the parameter as 23, and it will give the result of square root of 23, and it is assigned to the variable x here. These are some of the function calls examples what I have taken. Now, similarly, I have taken an example of another function called check even odd. I am passing 41 as the parameter here, and we have seen that the declaration, the check even function parameter is of type integer. Similarly, for absolute also the variable is of type integer was the parameter there. Now, here I assume that x is a variable of type integer. I am passing here as the parameter to the absolute function, and even for check even odd I am passing 41. 41 is an integer type, and even check even odd function is also expecting an integer as a parameter, performs the operation and gives the result as a z. And what could be the result here with respect to check even odd? The 41 is being an odd number, the check even odd function return the value as a 0. The z will get the value as 0 because the number 41 is an odd number. So, this is the way how exactly I can make use of function calls. Now, so based on this return type and the parameter what a function is taking, we can have the 4 different types of categories of the function. So, based on the return type and the function parameters, the one is like function with the parameters and not returning any value. Certain times in some situations a function will take the parameter, but it does not return any value there. And similarly, we can have a situation wherein a function with the parameters and returning some values. The function may take the parameter and also may return some value. In certain situation, functions may not take any parameters and also not returning any value there. And also in some situation a functions may not take any parameter but return some valid value over there. So, based on the return type and even the parameters what the functions are taking, we can have 4 different categories of functions. We will see one of the, each one by one along with a program. Now, look into this particular program carefully. So, here the statements which are similar like already we have come across certain statements here. One is like hash include stdio.h, this is a file inclusion statement, and this is most important here. So, here this is the function declaration or the function prototype or the function signature. So, this says through a compiler that, so here, so I will be using a function called check even odd, name of the function, and it is taking a integer as a parameter and it is returning nothing. We are not mentioning here what exactly the function check even odd is doing, rather we are mentioning the name of the function, what type of parameter it is taking, and also what is the return type of the function there. And then we start with the main function. This check even odd is a prototype of the function here. It is not absolute here, basically it is so prototype of a check even odd. And then in the main function we will see the certain declarations here. Num is a variable of type integer, then I am printing a message here, enter an integer, and then I am reading the data there. See here, when I am using the printf and scanf, these are the library functions. When I am using these library functions, it must be associated with its prototype also. That is the reason the meaning of printf, scanf, all this is present in stdio.h, wherein I can know the meaning of printf and scanf. So is the reason we have to include here stdio.h. If we do not include stdio.h, sometimes we may get the error as the function printf should have the prototype, because the compiler will not be knowing that who is printf. Here also what happens is like with the function prototype, you are telling to a compiler like in future I will be using a function called check even odd, so which is taking integer as a parameter and is not returning any data over there. Now, so this particular function prototype will inform the compiler about the signature of the function or the declaration of the function or the function name, so which is used in future of this execution of the program, and what type of data it is taking as parameter and what is the return type of the function there. And if it is not mentioned there, and when I start using the check even odd function here, when I am making a function call here, the compiler will get a confusion. You will not be aware of, compiler will not be aware of what exactly the check even odd is. So, normally the execution will start from the main function, but compilation will start from the very first line of the program. So, very first line here is the statements of the stdio.h, that is compiled one by one, and when it comes to this particular line, the compiler make a record that there is a function called check even odd which is taking integer as a parameter and return type is void. So, when it comes to this particular function call, the compiler is already aware that there is a function called check even odd which is taking integer parameter and not returning any void, any particular type of data there, because of which the compiler will not give you any error. Now, in case if I I am not mentioning this function declaration here, that time when it start compiling line by line from the first line, very first line of the program. Now when it comes to this particular line, check even odd, this particular line will says that there is a function called check even odd, but compiler is not aware of that. So we may get the error as the function check even odd should have the prototype. So is the reason. So before we make a function call, we have to specify the prototype of the function. Basically the C programming rule is like, before we make a function call, either the prototype of the function should be declared or the definition of the function must be defined. So either prototype or the definition. Since we are doing the prototype here, so definition part we are doing at the end. So now after that, so reading a num here, so we will be calling a function called check even odd. This is a function call here I am making from the main function. So the control will be from the execution start from the main function. It will come here, it will read the data of num, it will read the value of num, and then it will call the function check even odd num. The num is the whatever the value I enter, that will be passed as a parameter, and the control will go for execution of the check even odd function. When it comes to this particular function, we can note that I am closing the main here itself. This is another definition of the function check even odd. We can never define one function inside the another function. Like within one for loop, we can have another for loop, that we call it as a nested looping constructor. Similarly, within one if, I can have another if, that is a nested if else statements. Similarly, we cannot have a function defined inside another function. Here I am not defining the function check even odd, rather I am calling the function check even odd here. We should make a note that whatever the value I am entering here, that will be passed as a parameter, and this value will be copied to the variable x, which is declared in the function definition check even odd. When I make a function call here, the control will come to the function check even odd. So here I am defining the function check even odd, and here int x is a variable of type integer here, and x mod 2 is equal to 0, then it will display like number percentage is even. So otherwise it displays that number percentage d is odd. So it is going to say whether a number is even number or a odd number. That is the purpose of check even function, what I am trying to use here. And now we can see like this is the category of the function which takes the parameter and does not return any value there. So this category is function with parameter and not returning any value. So here the function is not returning any value. If I am returning any value, I must use a statement here return. And you can see like main is, it is not taking any parameter, but is returning a value of type integer. So is the reason we mention here return 0. If we do not mention return 0, I may get a warning here, like I will get a warning here like the function main should return a value. Even in spite of having warnings, sometimes we can execute the program, but problem is when we have the errors, we cannot execute the program, we have to rectify the errors there. Warnings means like this is a recommendation. So when when we are programming, and errors is like, so when we have the errors, we can never execute the program. Sometimes even when you are getting the warnings also, we can execute the programs, but when you are getting the errors, that must be rectified, otherwise the program cannot be executed. Now this is one example of program that makes use of a user defined function check even odd, which is taking a parameter and not returning any particular value over there. Now, so we see the another category of function, and before that if you see the output of this particular previous program, so here, so we are taking an integer data, passing it to a check even odd function, and it prints whether the number is even number or an odd number. Now the output of this program is like enter an integer, I am entering a value as 25. Now this 25 is passed as a parameter to the function check even odd, and that function is printing here the number 25 is odd number. So now once again when I executed the code, so I am entering the data as 26 here, enter an integer 26 I am entering, and that time the check even odd function is displaying the result as the number 26 is a even number. So likewise I can make use of the function. Now let us see the another example of the function. So this is a function prototype here, and it is taking a parameter of type integer, and it is returning a data of type integer. This is a category of the function which takes parameter and returns some value there. So taking a parameter and returning some value there. Now so the main function, so here I am declaring two variables num and answer, both are of type integer. Now enter an integer I am asking, I am reading the value there, then answer is equal to absolute of num. You have to see that num is what type of data here, it is an integer type. What type of data absolute is taking? Integer type. So is the reason, so what type of parameter the functions are taking, the same type of parameters we are supposed to pass to those particular user defined function when you are making a function call. This is a function call, this is a function prototype, whereas this is a function definition here. So now answer is equal to absolute of num. So I am passing a parameter as num to the function absolute. Absolute performs the operation. What exactly it is doing here is like it is taking the data there, the value of num will be copied to x here, and if x is greater than or equal to 0, I am returning x, because the absolute value of a positive value will be the same value itself, whereas absolute value of a negative value is the positive value correspond to it. Now else I am returning here minus x. I am passing minus 5 as the parameter here, then minus of minus 5 means it will be plus 5 only. So is the reason I am returning here minus x as the result, which will be the absolute value of whatever the parameter I am taking here. And x is what type of data here? Integer, and x is returned here. When I am returning the x here, I should note that what is the type of x is. X is of type integer, and the return type of the function absolute is also of type integer. This is the way how exactly I can pass the parameter and get the task done by the user defined function, or the function which is declared, which is defined by the programmer, and I can continue with my normal execution. We can note like the main function is making use of the user defined function for its successful execution here. After getting the answer here returned from the absolute function, the main function will print the result. The absolute value of percentage d is percentage d, that is the absolute value of num is the answer whatever we have got from the absolute function. And if you see the output of this program, and here basically the function is with parameter and returning some value. If you see the output of this program, here we have like enter an integer, we are reading 25 as the integer, we are passing 25 to the absolute function, and then we are returning the answer, and the absolute value of 25 is 25 only. Whereas when in the second run, when I am executing, so I am giving the input as minus 39, and here the absolute value of minus 39 is 39 is printed over there, because minus of minus 39 is plus 39 is the value returned by the absolute function. So this is an example of the program which uses the user defined function that takes the parameter and also returns some valid data over there. So this is the second category of the function what we have seen. And if you look at the another function here, the return type of this function display, the name of the function is display here, return type is void, it is not returning any value, and parameter what it is taking also, it is not taking any particular parameter there. Since I am not passing any since the function is not taking any parameter there, I am not passing any parameter to this particular function display. I am just calling this particular display function. This is similar to the CLR-SCR. You do not pass any parameter to the CLR-SCR function, which is used to clear the screen. So now here what exactly happens in this particular code is like I am just calling the function display here, and before that I am printing a message, the string is. So what exactly display is doing, like it is just printing a string called edusat there. So the return type of the function is void, and here also I am not mentioning any data there, because the function is not taking any parameter there. I can specify here void, or I can leave space there, means I can just so open and close the opening and closing parenthesis. This is most important. So in case of arrays we use the square bracket, in case of blocks we will be using opening and closing flower brackets, whereas in case of function calls and the function prototypes and in the function definitions we use here opening and closing parenthesis. Fine. So display I am calling here, so without any parameter there, because it is not taking any parameter, and when I call the function it will come to the display, and in the display function it print a message called edusat there. It prints a string called edusat. The overall what will be printed on the screen is like from the main function the string is printed, and followed by from the display function edusat is printed there. So this is a function wherein it does not take any parameter and even does not return any data there. Function without parameter and not returning any value there. The output of this code will be like the string is edusat. This is the sample output what we get when I execute this particular code here. You can take even the printf is also the library function provided present in stdio.h. This also opening and closing parenthesis we can see, and within a double quote whatever we pass here as a parameter that will be printed on the screen there. Now so this is the category of the function which does not take any parameter and even does not return any value there. Now, look into the another function. So, where I am calling the name of the function as a square, square, the square is the name of this function, and see in the name of the function what name I am giving, the same name I should use even in the function call also and even in the function prototype also. If there is any change even with a lowercase and uppercase or with a single space or whatever it is. So, anyhow spaces are not allowed in naming an identifier. Even if I am using uppercase and lowercase mistakes there, the C language is a case sensitive. Whatever the name I am giving here, the same name I should use even in the function call also and even in the function definition also. And one feature what you can see here is I am declaring a variable as num, which is outside of any function body. So, I am not declaring a variable num inside of this main function. So, this is a special case which you are coming across for the first time. So, here num is a variable of type integer which is declared outside of any of the body of the function. This is the body of the main function, this is the body of the square function here. Here I am not declaring the variable as num, whereas I am declaring num as a global variable. So, this here I am calling this num as the global variable. When I declare a num something like this, now this particular variable num is visible for even the square function also, even for the main function also, and even for all other user defined function of my program. This is called as a global declaration. So, we will see in the next session what exactly the global declaration and the local declaration is. Now, here ANS what I am declared here, this is a local variable which is visible only to the main function. So, we will let you know in the next class. So, what exactly the meaning of scopes and all that, and how exactly we call this as the local variable, why we call this as a local variable in the next session. But right now, so num is a variable of type integer, it is visible for the square as well as to the main function. So, is the reason when I ask for a number, enter an integer to find its a square, what I am trying to do is I am reading the num. So, num is the variable of type integer declared globally. So, the main also will be knowing that num is a variable of type integer. So, it will read the data properly there. Then answer is equal to square. I am calling this particular function. When I call answer is equal to square, the function square will be called, and in the square what I will be doing there is I am multiplying num into num, since square can also see the value of a num because num is a global variable. Whereas, so and hence, so when it does num into num, it will get the product and it will return that particular value, and this particular product is also of type integer because num is a variable of type integer, and the product whatever it gets, it is computing the square of a number, and that will be assigned to the answer variable there. When when the ANS will get the result of the square of a number num, then later part the square of the value percentage d is percentage d num comma answer. So, that is going to be displayed as the output of this particular the program. Now, so here we can see like the square is a function which it is not taking any parameter, and its return type is of type integer. So, now the functions without parameter and returning some value. So, this is the case where exactly, so we see a function without any parameters, it is returning some value there. Now, the output of this code is like enter an integer to find its a square. So, 5 if I am entering, the square value of 5 is 25 is the output what I am get, and similarly when I am entering the data as 9, so enter an integer to find its a square. When I am entering the data as 9, so the value of that 9 square what I am getting here is 81. So, this is the way how exactly we can program. So, all the 4 types categories of the function we have seen, that is with parameter, so with return type, with parameter, without return type, similarly without parameter and return types. So, we have seen, so all the 4 types or 4 categories of the function that is commonly used in the programming. So, in the next class we will see the 10th program, so which is to design a user defined function to perform the right shift operation, where so we will be performing the shifting of the bits from right rotation, we are performing the right rotation. So, what exactly we do in case of right rotation and all that we will see in the next session. So, thank you.